Welcome, Dr. Robert W. Stoker. You are Senior Manager at Boeing for Noise, Vibration and Emissions. Since 1996, he's worked with Boeing a long time, and there he held several functions. He was Vice Program Manager, among others, for the research and development of Boeing in the area of acoustics. He cooperated a lot with government agencies and universities. He worked in the development of quieter high lift systems and low noise engines for potentially new vehicles. In 2014, he headed the Eco Demonstrator program, and the Technical University of Darmstadt presented that before. This is a development program for environmentally friendly and progressive technologies. So we would like to know the results of that. We got some hints about it. And in your presentation, you will talk about the significance of air noise for neighborhoods close to airports. We have many city representatives close to the Frankfurt airport here. Then you will talk about efficiency versus noise protection. That's a subject that we are talking about in these 2 days. That is climate protection and noise protection, and whether the two can benefit from each other. Then you will talk about noise protection measures for the landing gear and the engine, and you also talk about the flight demonstrator of NASA and Boeing. Well, we'll do it just as before. If you need less than 30 minutes, we can have direct questions. If not, we will collect questions later for the question round. We are looking forward to your presentation.
Thank you very much. I appreciate it. Much like Stefan, I would only be able to speak in English and Spanish, so I apologize for having to give this in English and not German for you. And the other thing I'd like to say is mostly just ditto to what just saw. A lot of the same themes you're going to see from Boeing that you saw from Airbus. I think in a lot of this we're very aligned despite our competitive nature. So just like Stefan, we fully buy into the ICAO balanced approach towards noise. And really those same 4 pillars, looking at how do we reduce the noise at the source, at the airplane level. What do we do about land use around airports, noise abatement procedures and operations, and then very last, those operating restrictions. And much like that, we think that operating restrictions should really be used as a last resort. We'd really like to attack the other 3 and find the way forward using those 3 before we're restricting operations at airports. So I thought I'd show this. I know you've seen it a couple of times, so maybe we can go through it quickly. I'd just like to point out a couple of things here. So this is the cumulative noise levels. So as you got mentioned earlier, we certify noise in 3 different points. We certify at approach, at takeoff, and then there's one that's called the lateral metric that we also measure, which is kind of a takeoff metric. And kind of sum those up and look at them relative to the rules. And so you see the various rules that have happened down there. And then I've shown maybe predicting the future, some kind of blue bars or blue fuzzy circles out there. So right now the ICAO system is working through their process for developing new noise regulations and what those noise regulations might be. And so, you know, roughly we think it might be 5 to 8 dB lower than what it currently is on a cumulative basis on the next one. And then it seems like these things are starting to come around about every 10 years. And so then in about 10 years' time, they might drop another 5 out in that chapter Y area. We don't know what those will be called or exactly what they'll be, but something along those lines. And I think we ought to look at this, and just like was mentioned earlier, like we've made some pretty good progress. And when you look at airplanes coming down over the past 50 years, a lot of that has come through the bypass ratio increases we've talked about, the improved aerodynamics of the airplanes, and looking at those things. And so we have made a lot of progress. To me, you know, it looks like it's kind of flattening out. It's getting harder. We don't have those easy things to go pick off and reduce the noise by just massive amounts. It's getting hard, and we're digging in to try and find those things. And so we'll talk through some of those types of issues. At the same time, we're seeing increasing scrutiny on noise. I would say over the last 10 years, you've not heard a lot about noise. I think local airports hear a lot about it. A lot of the larger government organizations hear a lot about, it's been carbon. So a lot of the NGOs, the non-governmental agencies that are out there, talk a lot about carbon emissions. But really over the last few years, we've seen some changes happening and seen some increased scrutiny on noise exposure again. And so the World Health Organization put out a report in 2018 that talked about noise exposure and the influence it might have on people's sleep and how the health effects of that might happen and impact people. The FAA in the United States did a survey on noise annoyance, and I'll show a couple of charts, or a chart on that in a second. Hong Kong International put a new airport restriction into its process called the QC system that's slightly different than the London Heathrow QC system, but again, just another way to kind of look at things, and looked at nighttime curfews for certain 747s. So kind of that impacted us. We're seeing increased noise fees at London Heathrow, and even a brand new noise fee level that's coming in 2022, or came in 2022. And then, like I just talked about, new noise regulations in 2025. And so, I'd say after a period of a lot of talk about carbon emissions and all of that, these last 4 or 5 years, the pendulum's kind of swinging back more to that balanced approach between carbon and noise, which I think is a good thing. And you're seeing it, I'd say, from the same thing on Airbus. And hey, we're wanting to increase that kind of research and technology again and get that back in there. So this is a really interesting survey. So this survey came out in 2021, but it's really based on data that was collected in about 2015. And they went out and surveyed a whole bunch of airports in the United States, both big and small airports, and asked about noise. And they did this well, I'm not a detailed person on how you go out and actually do surveys like that. They had experts get involved about what are the right questions. So they didn't go out and just ask, how bad do you hate airplane noise, right? Because that would be a terrible question to ask, and everybody would say, we don't like airplane noise. But they asked about noise in general, and so they asked about lawnmowers and things like that around, so that they could get an idea of just how noise was bothering people. And then out of that, they broke out the parts that indicated airplanes, so that they could get a different thing, but it wouldn't be biased just against airplanes. So if you look at the curve on the left, this is a curve that the FAA uses to think about how they're going to soundproof houses around airports. And it's called the Schultz curve. And it really came out in 1978. And basically it said that if you have 65 DNL, yet another noise metric, and I'll talk about the DNL metric here in a second, but what it basically says, if you're below 65 DNL, you've only got 10% of the people that are highly annoyed by the noise, okay? And then when they did this survey in 2015, 2016, that got published in 2021, it came out, and when they did that, it came out and said at 65 DNL, about 60 to 70, and you see the error bars are in the blue up there, people are now highly annoyed. And so they're trying to understand, have we just moved on from how we understood noise? We like to talk, some of us that like airplanes and airplane noise, we talk about the sound of freedom in the United States, right? The big booming sounds and exciting and all of that. But the reality is that's not the day in, day out. But people are starting to say, hey, those sounds that were not annoying to us now, maybe it's because things are quieter or whatever else, are now annoying to us. And so they're doing that. This DNL curve is an interesting curve and an interesting metric to use for noise, because it accounts not only for how loud a given airplane is, but the number of airplane movements that happen in an airport. And so it's kind of a summation of what happens over 24 hours. So if you have 10 airplanes that fly in at 80 dB, that'll give you a number. But if you had 20, it'll go up. If you had 30 all at the same level, it'll go up and up and up. And so it tries to account for the total number of flights in and out of an airport. So this is just another case where we're really seeing that, hey, that national curve is changing pretty significantly. And nobody's quite sure what's going to happen. I don't know how this is going to impact the rules and regulations we talk to. I don't know how this is going to impact what the FAA wants to do around airports. Everybody's still trying to understand what this means, but it is an indication that some of the levels that used to be thought of as, hey, you're in a good spot there, we may no longer be in a good spot. We talked about some of these things today, some of the configuration changes. And I'm not going to go into details about our airplanes. There are certain pressures that we're having that are coming on. And so just like in the first set of presentations today, they talked about hey, weight is a problem for airplanes, and trying to improve the weight is going to help you improve the overall carbon efficiency of the airplane. And so we call that the compact nacelle. How do we shrink all the area around the engine, all that cowling that you see around the engine? How do we shrink that down to reduce the weight on the airplane? But when we shrink all of that down, it takes away area that we had for acoustic linings. And so one way you can look at it is, just the more acoustic linings you have in those areas, the more sound you're going to absorb. And so now we don't have that same area to absorb the sound. So what are we going to do with that? Sometimes, and while we're doing better on flaps and flap side edges, as we try and drive towards those improvements, we might end up loading up the flaps higher. And so then when you do have a side edge, you might get a stronger side edge vortex off of it, which will increase the noise. So we got to think about that. The fan system architectures we talked about earlier today, talked about what's happening in the fans. Those are becoming larger, and so that's changing things. In some cases, they're more tonal. We're seeing things sometimes out of turbines on the aft end of the fan that were not necessarily problems in the past. As we've lowered the jet noise down, these things are now the tent poles that are out there. And if we're going to make progress in reducing noise, we've got to be looking at some of those things. And then the open rotor. This is another one where I totally agree with Airbus on, it's kind of unknown right now exactly how loud or how quiet that's going to be, if it's going to be worse or not. But one of the things that I'm concerned about is very much that psychoacoustics part of it, is that it may not be any louder than anything else that we've got flying out there, but the sound quality part of it may be very different. It might be more tonal, and that might be more upsetting to people than a similarly loud or quiet classic turbofan engine. And so we got to think about that even if it's the same absolute noise level, it may be more or less annoying to people, and so we're going to have to look at that. It's also a hard problem because you don't have a lot of places to put, like I said, it's out there in the open, and so you don't have linings to absorb any of that frequency sound that's coming through it. So we've got some struggles in there that we've got to work through. So what are some of the things that we're doing right now? So this got talked about. We've done a number of landing gear technology studies. I did a full-scale landing gear in a wind tunnel back in about 1998. We've moved on from there and tried to get some of those technologies in and around airports, some parts that are in and around our airplanes. Some of it's worked, some of it hasn't. We tested with NASA in 2001 a big landing gear fairing that actually, when we tested it, it worked really well in the wind tunnel, but in the actual airplane, it didn't seem to have much of an effect. And so it took a lot of us trying to dig into those details to understand it. In 2020, along with Safran, we did some testing on a 787 where we looked at kind of fairings that had those holes in there, so they weren't hard, and so the air could kind of both go around and kind of go through it, and drove through a number of those things to see, can we reduce the noise there, and saw a few dB in noise reduction on the landing gear component itself. And so that's something that's out there. Now what we're trying to work through, and we're doing additional testing as part of a flight test program that'll happen in 2024 and 2025, to look at some other technologies along with landing gear and kind of improving on some of those fairings. Some of the difficulties we have, and I cringe a little bit, no offense to the folks from earlier this morning, when people talk about the TRL levels, right? And they say TRL 6, hey, this should be, why is this not running into on your airplanes right away, right? And so the struggle is that technology readiness level is only one of the things that we have to think about. We have to think about, internally to Boeing, we call them the other ilities, and it's what about the certifiability of it? What about the manufacturability of it? What about the maintainability of these things? And some of those things can be very, very difficult to kind of overcome. One of the problems sometimes with some of the fairings is that pilots like to get out and look around and make sure that everything on the airplane looks good. Now, if you've covered up their landing gear with a bunch of fairings, they get a little concerned, and they don't get to see some of the things they used to get to see. And so then you've either got to put in hatches so that they can look into it, which adds more complexity, or do other things, or try and figure out how to make it clear. You have to make it capable not to have various fluids that might drip on it not come into problems. So some of these things are some of the problems that we've got to work through, that sometimes even when we show that it's a great noise solution, we've got to work through all those other things to make sure that we can actually go implement it in the factory or into the factory and onto our airplanes. So as part of the clean, we are looking at some landing gear fairings. We're going to look at some treatment of putting some linings on the door to see if that helps absorb some sound that comes from the landing gear that might come up and reflect off of that and down to the communities, see if that helps. We're also going to look at a number of things on the flap side edges, trying to look at almost like the sharklets that were out on the wingtips, but more on the flap edges, in addition to kind of other shapes of the flap side edge to see if that helps reduce noise. We've seen some successes of those types of things in the wind tunnel. Seen some successes in flight tests, and it's trying to find what's the right balance in there to kind of make it. Very similar on the landing gear, as you've seen. We've seen in some cases the nose gear is the dominant source. It depends on the frequency. In other cases, it's the main landing gear. They're often bigger. They might have other things. And then people talked about the tones on landing gears and trying to cover them up. And we've had that same problem with some of our folks about talking about corrosion in them and things like that. And so we found other ways to go reduce noise around the tones that are probably more similar to what Airbus did on some of their anti-ice vents, but we've put them on various parts of the landing gear that have holes and pins through them, and seen pretty significant reduction on the 787 from doing that to reduce those noise. So we're trying to look through all those things and trying to reduce the noise from those flow control types of technologies. Advanced linings. So this is another one that we think about, hey, if we're trying to shrink that nacelle down to make it smaller so that it's lighter, then we've got to get more efficient about our linings in there. And so just as they talked about, you can use multiple types of linings in there. You can have one depth and it's really tuned towards one frequency, which we usually pick the fan blade frequency of the nacelle coming through there. But you can actually then make it a double layer liner, and then you can pick two frequencies to try and tune. Maybe you can get into three and get maybe three different frequencies and get a little bit more broadband kind of reduction in there. But some of those things get hard to produce. We can produce them pretty well kind of on one-off cases and go do them in a flight test. But if you start thinking about the types of rates that we're thinking of for like a 737 or an A321 or something where you're starting to talk about 30, 40, 50, 60 a month, then you've got to have a production system that can keep up with that kind of a thing. And so that gets a little bit more difficult. And so that's another place that we need technology development, is not just on the acoustic side of it, but on the manufacturing side. So can 3D printing start helping us in some of those things? We're also looking at, as part of the FAA Clean program, we're doing some flight testing on different acoustic treatments. So this is more about, hey, how can we design acoustic treatments into other areas of the airplane or of the nacelle that maybe we didn't have acoustic treatment previously because it was hard or it was hot or other aspects that might have brought us down. And how do we minimize, you know, when you have a structural piece in there, it needs so much kind of space on it to be structural. You can't have the nacelle fall off. But how can we minimize that so that we can move the acoustic lining farther and farther up there? And so we're looking into all of those types of things. And then the other part is we're trying to see, can we get more acoustic lining going up around the lip of the nacelle, right? So going all the way forward that you see up there on that green area. That becomes difficult because in a lot of cases, well, in every case, our nacelles have anti-icing things in there. They have a flow that either heats it electrically or through hydraulic air pressure and heats it up to keep ice from building up on the nacelle. And it turns out that a lot of these acoustic linings also act as thermal linings. And so you've got to find different ways than you might have done previously to try and get both that anti-icing capability in there along with the acoustic treatments. So this is another just kind of integration problem that you have, that you can't just sit here and go, oh, we're going to go put all the acoustic treatments on there because we've got certification issues that we have to think about that might not be related at all to acoustics. They might be related to the safety of the airplane and flying through icing conditions and things like that. So a lot of our linings are looking at those advanced linings that we might use And then also, how do we get more and more area in there? Operational efficiency for noise, so this is in and around airports. Much like you heard earlier, we're trying to do everything in the airplane possible to enable it to fly more accurately around where it might fly, to bypass communities where it makes sense for the airport and their airspace, and just make sure that that capability is available to the pilots and the air traffic controllers to use. So optimized flight paths. Steeper glide slopes is one that's been talked about a lot. Instead of flying kind of at a 3-degree glide slope, what if you flew at a 3.5-degree glide slope, right? And so then you're a little bit higher over everybody's houses or the noise monitors and things like that, and that's going to give you just a little bit of natural quietness. Now, this has gone to some very strange extremes. I had one NASA people at NASA are great, but they don't always understand how airplanes always fly and work. And so one of the guys at NASA told me, he goes, I don't know why we don't just fly at a 12-degree glide slope, and then the airplane will be extremely high over everybody and not put the landing gear out until you're right over the airspace of the airport. And his answer was, we do it on the space shuttle. It comes in at a 12-degree glide slope, and they don't put out the landing gear till the last minute. I can tell you that I don't think I want to fly in an airplane that's on a 12-degree glide slope coming in. I think it would scare a lot of passengers, and that's not where we want to go. And I also have talked to many pilots, and they don't want to wait till the last minute to put out the landing gear before they're about to hit a runway. So, 12 degrees is not the right answer, but when we start thinking about things like, hey, maybe 3.5 degrees, and that for airports that have long enough runways, maybe instead of landing right at the threshold of the runway, maybe you can do a 1,000-foot offset, and that kind of comes down the runway a little bit farther, and you're a little bit higher over the communities around. So those are things, but it's very indicative on the specific airplane and the specific airport on which things you can do and how it fits into your air traffic management. So what we're trying to do at Boeing is we go out and we actually do work with airports on operational procedures around their airports in some cases. And then we want to make sure that the airplanes are enabled to take advantage of all of those opportunities. And then this is almost my last chart. So we have a sustainable flight demonstrator that's being done by NASA and Boeing. We call this the transonic truss brace wing. And improved performance is one of the things that we get out of that. So again, if you've got a larger wingspan, you're going to get improved performance. Sometimes it may be better to give up on some of the low speed that you heard about earlier, say fly slower, and say, well, okay, you're flying slower, but now you're over homes longer. Maybe the answer is go faster and climb higher. There's a balance in there, and so we try and do those trades. What's an overall good balanced approach on looking at those things? There may be some engine shielding that we get from that truss down there that we might be able to make use of to kind of help reduce noise. And then we're also going to think about, what might we do with landing gear again? We're probably on this airplane going to just take the landing gear that came with an airplane that we're going to kind of cut up and use. But there might be other things that we do down the road and try and look at it. And then we're going to try and keep this airplane and give it the ability to try other types of engine configurations, such as the CFM Rise engine we might put on there and see how an open rotor, open fan type of a configuration might work on this airplanes. One of the nice benefits of the higher wing is it gives you a really large space to kind of put large bypass ratio engines and large engines on there and see how that may or may not benefit you. And so it gives you a little bit of a different space that you can play in and try and figure things out. Okay, so this is my last slide, and then I'll take any questions, because I think originally we were told about 20 minutes. But I do want to celebrate our successes, right? We have made significant progress in noise reduction over the last 50 years. I'm not saying that it's what everybody wants and where we want to be and that we don't want to continue to make additional progress, but let's celebrate the wins we've got. Obviously, there's still a lot of significant concerns about aviation noise out there. Some of the technologies targeting carbon reduction may have a negative impact on noise, may not. They may be noise neutral, they may be noise negative, and we're going to have to kind of work through those balances as we start thinking about some of those things. And we're continuing to invest and develop technologies to reduce noise. We're not done, even though I like to say we've made a lot of progress. We're not done. We're still trying to both test in wind tunnels, test in flight, and improve our technologies, not just on the, hey, does this reduce noise, but all those other things. How do we reduce noise and make sure it's manufacturable, it's reliable, it's safe, it's certifiable, all the other things we need to do to go put it on an airplane and go forward. And with that, I'll take any questions you might have, or I'll get off the stage and let the next speaker come up.
Ja, vielen Dank.
Thank you, Mr. Stoker, for your presentation and for this insight into the measures that are possible, everything that you have carried out, and you explained all the problems in the implementation and the certification. You explained the whole bandwidth. At the end, you offered an outlook, how in the future you could have new aircraft architectures, and we are looking into that later on. And you also talked about approach and glide slope angles. Tomorrow we'll have a presentation on that by the DLR. That is how you can reduce noise because of this, but this is not the core issue of our conference. It's rather the technology directly at the aircraft. That's what you talked about. You talked about the engine also, and I think that's a very good transition to the next presentation. Well, there were no concrete questions to you, but I have a question to all of you. So also after the coffee break, we'll have questions, but I would like to ask these questions to all of you. Thank you very much to you. Thank you for your presentation. Give him an applause. Yeah, definitely.